And we are going to find what is the slope, what is the value of GM at IDS equal to IDSS. Okay, so when you put IDS equal to IDSS, so GM value will be, so these two currents are same. So GM value will be minus 2 into IDS by VP. Okay, minus 2 into IDS by VP. Or you can also substitute IDSS. So minus 2 into IDSS by VP. Both are correct. And I am rewriting this one. So IDSS by minus VP by 2. Just I'm bringing the 2 to the denominator. You are understanding what I am saying here? After finding out all these expressions, what I am saying, I am just analyzing the condition, what will happen when IDS equal to IDSS in the expression for GM. So this is the expression for GM. In the expression, I'm substituting IDS equal to IDSS. Wherever I have IDS, I'm replacing by IDSS. So this IDS will be replaced by IDSS. So you get minus 2 into IDSS into IDSS. If you take square root, you'll get only one IDSS by VP. And this 2, I'm bringing it here. So it is IDSS by minus VP by. So this shows that exactly when you put when you what they are saying is you have an intercept of minus VP by 2 on the axis. See the graph, exactly at minus VP by 2 you will have an intercept. Intercept means when you draw a line and measure the value of that particular voltage, it will be exactly VP. So, and they are saying how you can measure the value of VP is when you put VGS equal to 0, at that point you draw a tangent to the curve and find the value. So see here this graph. So at this point, VGS equal to 0, you draw a tangent. You know what is a tangent? Tangent, no, it will touch the curve only at one point. So if you draw a tangent and if you extend the tangent, whatever point it is meeting here, that is going to be minus VP by 2. So on the point on the minus VP by 2. So if you want to find VP, multiply this value by 2. That is going to be a pinch of voltage VP. That is what they are saying here. See here, we want to find the value of VP. What we should do, draw a tangent to the graph at VGS equal to 0. Okay, so that is going to be giving you the value minus VP by 2. So once you know minus VP by 2, you can find the value of VP by multiplying that voltage by 2. And you know that at pinch off, the device is said to be off, right? So that's another, I can represent VP by modulus of VGS off. See, everywhere VP எழுதுறப்ப we'll put modulus because VP is always a positive voltage. Because VP is related to VDS. And VDS is always positive, correct? So whenever you find VP in terms of VGS, we'll be taking the modulus sign. So VP equal to, I'm just denoting VP as modulus of VGS off. So my final drain equation becomes ID is equal to IDSS into 1 minus VGS by VGS of the whole square. No change I'm doing. I'm just denoting VP by VGS of the drain. I'm denoting the pinch off voltage by a new term VGS off. It is pinch off voltage, right? So I'm denoting it by VGS off just to make my understanding very, very clear. Okay.